everybody, number 34. On the set of axes below, graph f of x equals x squared minus 1 and g of x equals 3 to the x. So the question wants us to graph these two functions on the set of axes below. Okay, so whenever you see a problem like this on the Regents, you're going to pull out your calculator, voila, and you are going to type in the first function. So let's type in f of x squared minus 1, hit enter. Looks like a parabola, fantastic. And then you're going to add the second graph. G of x is equal to 3 to the x. Okay, cool. This is a little busy. I'm going to move this label over here. I'm going to move this label over here. Okay, fantastic. Let's go ahead and get some points so that we can recreate these two functions on our set of axes. Let's go first to the parabola. I'm going to do menu 5, 3. I'm going to tell my calculator what to count by. I want it to count by ones. Then I'm going to go to menu 5, 1. And I'm going to put the blinky dot on my calculator. So it looks like I'm going to get a few nice points here. So let's go. Negative 3, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. That's my first point. Then I'm going to go to negative 2, 1, 2, 3. Then I'll go to negative 1, 0. Ooh, that's an x-intercept. And I'm going to go to 0, negative 1. I'm going to keep going. 1, 0. Then I'm going to go to 2, 1, 2, 3. Then I'm going to go to 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. And that looks good to me. I'm going to connect my points. And I'm going to label my graph. Oops, that's f of x. Lo siento. F of x equals x squared minus 1. Now let's head over to the other graph, the exponential. Now, if I want to move to a different graph on my calculator, if you'll notice, the color of the blinky dot here is blue. I am on the blue graph. Let's move to the red graph. You can hit the up arrow, and that'll move you to the next function. So now, see how my blinky dot is red? That means I'm on the red function. So I'm going to look for some good points on here. 327 is way off my graph. I'm going to go down a little bit. 29, ooh, that's on my graph. I'll do that one. All right, so 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 3, 1, 1, 2, 3. And then 0, 1. And then, oh, look at this. Negative 1 is going to have a y value of 0.33333. That's about 1/3. So I can put my point about 1/3 up. Then as I get further and further out towards my my negative x values, it looks like the y coordinate is approaching 0. So I'm just going to kind of approximate this asymptote here. Have it approach 0, but never touch as we head out towards infinity. Okay, I'm going to label this guy g of x is equal to 3 to the x. Okay, I've produced two pretty good looking graphs. I'm going to keep looking at the problem and see what I got to do here. It says, based on your graph, for how many values of x does f of x equal g of x? Explain your reasoning. Okay. Well, on my picture, it looks like f of x equals g of x, aka where do they cross? Right here. And now, is the question asking me to say the x value where they cross, or is it asking me to say how many times it crosses? Let's go back and read because I forget what it says. It says, based on your graph, for how many values of x? Okay, so it's just asking how many times do these two functions cross? Well, visually on my graph, I just see that they only cross one time, right? So I'm going to say that there is one value of x where f of x equals g of x. This answer would not give me full credit because I did not explain my reasoning. My reasoning is going to be because there is only one point of intersection.